Lots to keep track of.
Yeah. Okay. So we're going to start with the opposite on the cubed root of the values you found from your y over here, right? So you found 1, 8, 27, I assume. 0. Okay. The cubed root of 0, what times itself 3 times gets you 0? 0. What times itself 3 times gets you 1? 1. 8, 2, 27, 3. So when you plot this, you go 0, 0, 1, 1, 8, 2. So it looks like this. What about the negative side? Can you have negatives in a cubed root?
Wait, yeah. Yes.
Yeah, right? Because what is -1 cubed? -1. So you could have -1, -1, -8, -2, -27, -3. So it looks like this. Right? What do you notice about these graphs?
They're wiggly.
Huh? They're wiggly. What about from this one to this one? What does it look like? Yeah, what were you going to say, Carter?
I was just going to say if it's squared, and it's just like a little gravel, so it's just up, like, or down, and it's cubed, it's going to be times up with last two.
Yeah, so cubed gave you a squiggly because it has positive and negatives, right? Your squared is just positives, or just negatives if you have a negative on the outside, right? It could flip. And then what about going from the squared to the square root? What does it look like? That goes like, show me with your hands. What does it look like? So this is squared. Now go to square root. Yeah, same with the cubed, right? Cubed root. Okay, so it's like they're laying down. Let's move on. So this one was really hard to understand in the last class. So I think we're going to work on this together and just kind of come up with ideas, okay? You have to come up with an equation where if you plug in -4 and then somehow square root it, you get a 0. What do you think that's going to be? Someone raise your hand. What will your radical function look like if you plug in a -4 and somehow come out with a 0? Yeah.
You just multiply it by 0.
You can multiply it by 0, but that would just be a function that looks like the square root of 0x. So does that work if you plug in -1? Will you get -3? Or sorry, square root of 3? No. What's another way that we could get from -4 to 0? Add 4. Let's look at that. The square root of x plus 4. Plug in -1. Does that work? Yeah. Okay, so let's plot those points on the graph. And what does it look like? So where do I go for the -4, 0? Someone raise your hand. That I haven't heard from. Holly, where do I plot -4, 0? Okay. And then James, where do I go for -1, square root of 3? Or were you the one that raised your hand, or was it behind you? Where do I go? Somewhere here, right? Yeah, okay. And then where do I go for 0, 2? Lizzie. Up 2. So it looks something like that, right?
Couldn't you just use the 1, 3, 5 rule? So it goes 1 and 3 and then up 1 over 5, up 1 over 7. And you just do that for the rest of the equation.
What's the 1, 3, 5 rule for? Is that a parabola?
No, but it's half of 1. And it follows it the first ones.
So it follows it towards the side.
Well, because it's
It's half of it.
well, and it's to the yeah.
So you need to do the opposite numbers.
Instead of over 1, up 3.
It's up 1 over 1,
Yeah.
up 1 over 3,
Yeah.
up 1 over 5. Yeah.
Yeah, you can follow that.
Alright. Just to graph it.
Starting from that -4, 0, right?
Yeah.
Okay.
Like that.
Anyone have any ideas what would happen here? How do we get from the -4 to the +1?
It's a Q0.
So it's a,
No.
this is still a square root.
Plus 5.
Okay, if I put in +5, will that work for the 1 plus the square root of 3? So your numbers don't have to be inside of the square root function.
It's a 1 plus the square root of x plus 4.
Yes. Does that work for all of them? Go ahead and check and give me a thumbs up if it works. Did it work?
So,
So does it not have an x-intercept?
I don't think so. When I graphed it using the points that they already gave us, it would look like this, right? And we can't have any negative y outputs. So no, it won't have an x-intercept. Okay, I want you to think about this point right here. This, you called it critical point, didn't you? Okay, this point right here where it moved the graph, what happened from these numbers to get it to here?
So plus 1 on the outside.
There's a +1 on the outside. What did you notice about the graph though? When there was a +1 on the outside, what happened to the graph? Someone that hasn't answered yet? Maddie.
thought it went off the x-axis.
It went off the x-axis. How many times? Once. Okay. What about where the original graph was right here? What happened when we added a 4 inside the square root?
Oh,
It went back.
It went back 4. Does this ring any bells?
This is vertical and horizontal shifts.
Yeah. That's so pretty. Is this what's on your paper? Or did it totally skip this?
No, that's what's on the paper.
Okay. This is a little bit different than their papers. Okay, so I want you to think about that as you Plug in values and graph these 4 equations, okay?